Okay, Algebra 1, here's our test review for our test on Friday. And I'm just going to start by going over what we know so far. So, first bullet point. The graph of a quadratic function is a parabola. It is a parabola. And most of the time, we can factor to find the x-intercepts. X-intercepts are also known as zeros. And we can do that when we set f of x equal to 0. You can see those in orange right there. Next, the blank is either a max or a min and is on the blank of symmetry. Well, what we can see right here in green is the vertex. The vertex is either a maximum point, like this one, or a minimum point if the parabola is opening upward, and it always lives on the blue line here, the axis of symmetry. Okay, moving up. We can easily find the blank when we let x equal to 0 or just identify the constant in the problem. And that is the yellow point here highlighted. That is the y-intercept. The y-intercept. And there's only going to be one of them. There's two x-intercepts if the graph crosses the x-axis, but there's only going to be one y-intercept. Okay? All parabolas are symmetrical, which is why we have an axis of symmetry. So your graph should look exactly the same on the right and on the left. It shouldn't be lopsided and one side bigger than the other. So think about that when you're graphing your parabolas. And if your equation is not factorable, we can use the vertex formula. And that's what we've been learning about this week, and we're going to see a problem using the vertex formula in this video. So here's everything we know so far. We're graphing parabolas. We can factor to find the x-intercepts or the zeros. To do that, you replace y with 0 because y and f of x are the same thing. The vertex is either a max or a min, and it's always on the axis of symmetry. Remember that the axis of symmetry is a line. So the blue line here is actually x equals 2. If you just put the whole number 2, I'm going to take points off. I want you to write the equation of the axis of symmetry. We can easily find the y-intercept when we let x equal 0 or just identify the constant. All parabolas are symmetrical. The left-hand point should mirror the right-hand point. And if our equation is not factorable, we can use the vertex formula. Let's do some examples together. So, we started this chapter by solving by factoring. Why? Because we spent all of chapter 7 learning how to factor. So if I tell you that we can solve by factoring, the first thing you should do is replace y with 0 and then factor the polynomial. So 2, 1, none. It's in standard form. So let's try to factor this. So 2 is prime, so I know I need 2x and 1x. And if I put a 5 here and a 3 here, 2 times 5 will be 10. 3 times 1 will be 3. 10 minus 3 is going to give us the negative 7 in the middle. So we need our 10 to be negative and our 3 to be positive. So those are our factors. Once our polynomial is factored, we will set each factor equal to 0 and solve for our two solutions. So minus 3, 2x equals negative 3, divide by 2, x equals negative 3 halves, plus 5, x equals 5, x equals 5. There we go. So these are our two solutions found by factoring. Both of them we could plug back in and they will both make the equation true simultaneously. We now know that if we were to graph this, and I'll show you what this looks like on my calculator, we can see that the graph is going to cross the x-axis at those 2 points. So let's plug this in. 2x squared minus 7x minus 15. And we can graph it. And it'll look a little bit better if I hit zoom 4. And we can see that this particular parabola is crossing at x equals positive 5, 1, 2, 3, 4, 5, and also at negative 3 halves. Remember, negative 3 halves is the same as negative 1.5, so negative 1.5. Remember, these solutions, when y equals 0, represent the x-intercepts on a graph. Next, solve using the square root property. If I ask you to solve by using the square root property, step 1 is to isolate the squared term. And of course, all of these videos that go over each one of these specifically are on the Google site for Chapter 8. So all you have to do is go back a few pages. So for us to isolate the squared term, the first thing I need to do here is find the squared term. So all of this is the squared term because the quantity is raised to the second power. So I'm going to divide both sides by 2 in order to get the squared term by itself. So now I have 5x minus 3 quantity squared equals 6. So from here, I'm going to take the square root of both sides. So after we get the squared term isolated, we will square root both sides. Remember, the square root undoes the square. They're inverse operations of each other. The square root undoes that square. So cancel, cancel, and we get 5x minus 3. And of course, we've got root 6, but it's positive root 6 just as much as it's negative root 6. Now I've chosen something here that doesn't simplify just to remind you it's not always going to be a perfectly happy, perfect square number. Sometimes it's going to be an irrational number, something that's a little more extra like this one is. So from here, we're going to set up our two equations because there are two solutions here. So 5x minus 3 equals positive root 6. 5x minus 3 equals negative root 6. And from here, let's solve for x. Plus 3 plus 3. 5x equals 3 plus root 6. These are not like terms, therefore they are not going to be combined. They're just going to stay 3 plus root 6, and that's fine. Divide by 5, divide by 5. X equals 3 plus root 6 over 5. That is an irrational answer, and that's fantastic. Just leave it. Plus 3 plus 3. 5x equals 3 minus root 6. Divide by 5, divide by 5, and that is our answer. It just changes the sign in front of the radical. These are called irrational, two R's, irrational roots or irrational x-intercepts. And that's fine. We can have those. 1, 2 answers. But what's firm here? Isolate the squared term, take the square root of both sides, solve for x. Remembering that we are after two answers here. Next problem, graphing. And this is a very simple one. We've seen this particular polynomial a few times. We can easily factor it. Factors of negative 3 that add up to negative 2 are x minus 3 and x plus 1. So it's easily factored. So this is factored form. Let's set it equal to 0 and solve to find the x-intercepts. This was the graphing by using x-intercepts, graphing by factoring. So set each one equal to 0, x equals 3, x plus 1, x equals negative 1. So if we go to our XY chart, when x equals 3, y equals 0. Remember, we replaced y with 0. When x equals -1, y equals 0. Let's plot those points. Back 1, up 0, over 3, up 0, which gives us an axis of symmetry at x equals 1. Remember, it's not just a number, it's an equation. Write it as an equation. The axis of symmetry is at x equals 1. Be sure that you write the equation. So what are we going to do with that 1? We're going to plug it in because we need to know the vertex. So what is y when x equals 1? This is an input. We need to get an output. And in order to get that output, we have to evaluate the function when x equals 1. So y equals, and I'm just going to plug it in the factored form. So 1 minus 3, 1 plus 1, that's -2 times 2, that's -4. 1 -4 over 1, down 4. So let's don't stop there. Let's find the y-intercept. The y-intercept is the easiest point to find. It is only the constant. So when x equals 0, y equals -3, plot that point. Use symmetry in order to reflect and find the other point, which is there. And let's just be super competent here. Let's plug in a 4 just to get a 6th and a 7th point, because we can plug in any x value that we want. Not all of them make a lot of sense. Obviously, if we plug in 10, the numbers are going to get high, but 4 should work out nicely. I'll plug it into the factored form. Y equals 4 minus 3, 4 plus 1, that's 1 times 5, that's 5. Over 4, up 5. So 1, 2, 3, 1, 2, 3. Can make a nice parabola. It's a nice smooth curve. It's not pointy, it's not jagged, and it has arrows on the top. That's what I'm looking for in your work. Last problem for our review video here. This problem is not going to factor. So we are going to want to use the vertex formula. So the vertex formula, the first thing I got to know, well, what is A, what is B, and what is C? If we're in standard form, which is 2, 1, none, there's A, there's B, there's C. So A is -2, B is 4, C is -3. We're going to find the x coordinates of the vertex by taking the opposite of B and dividing it by 2 times A. So that's going to be the opposite of 4, which is -4, over 2 times -2. That gives us -4 over -4, which is 1. So think about your XY chart. Our x, our input, is 1. And in order to get both parts of the vertex, the x and the y, I need to take my input and evaluate the function. Now this one doesn't factor, so we're just going to have to plug it in and evaluate. So f of 1, that's -2 times 1 squared plus 4 times 1 minus 3. You need to use order of operations, square first. So 1 squared is 1, 2 times 1 is 2, 4 times 1 is 4, minus 3. So -2 plus 4 is 2, 2 minus 3 is -1. 1, -1. Our vertex is at 1, -1. Over 1, down 1. That's our vertex. Now here's the other thing I know. I know that our A value is -2. That is the leading coefficient. And if the leading coefficient is negative, this parabola is going to open downward, which means this vertex is a maximum point. which means that -1 is the maximum y value. All right, let's plug in something else that's easy. Let's let x be 0. If I let x be 0, just a reminder, it's going to cancel out the first term and the second term, only leaving the constant, -3. Over 0, down 3. So if we come and draw in our axis of symmetry, which I'll be looking for on your graphs, my axis of symmetry, A of S, is at x equals 1. The equation x equals 1 represents that vertical line. So if I have a point 1 unit to the left, there'll be 1 unit to the right. So next, we can choose what we want to plug in next. We could plug in a 5 or a 6 or a 7, or a -7, -8, -9, but then the point is going to be way off the page. So plug in something close to 0, 1, or 2. So I'm going to go with 3. Let's plug in 3. So this is our input. We need an output. So f of 3 will be -2 times 3 squared plus 4 times 3 minus 3. Follow order of operations. 3 squared is 9. So we're evaluating the exponent first, then multiply. -2 times 9 is -18. 4 times 3 is 12. Minus 3. That is -6 minus 3. That is -9. So when the input is 3, the output is -9. Over 3, down 9. This is a tall, skinny parabola. 1, 2, 1, 2. I'm using my axis of symmetry. And now here is what my parabola looks like. I'm looking for this work when you submit a picture of your homework and work on a quiz. This is what I want to see. On the previous problem, same thing. If you are setting it equal to 0, factoring and solving, I'm looking for this work every single time.